Today we're covering triangle congruence. This triangle congruent to triangle. When two triangles are congruent, all of their other parts are equal. For example, you have 3 congruent angles and 3 congruent sides. Take, for instance, this similarity statement right here. Triangle ABC is congruent to triangle XYZ. Let's list all of the congruent things. Like we just stated, all the angles are congruent. This statement tells us exactly which angle is congruent to which. If I look, the first letter given in the first statement is A, and the first angle given in the second statement is X. So I know that angle A is congruent to angle X. And I keep going. Angle B would be congruent to angle Y. And angle C would be congruent to angle Z. Okay, so that's angles. But now let's look at sides. I know the sides are also congruent. The congruency statement also shows you which sides are congruent. If you look, your first side stated is AB, and that's a segment, and that would be congruent to the first 2 letters on the other side, XY. Then look at the next 2 letters, BC, and that would be congruent to YZ. Finally, you look at the first and the last letter, AC, and that would be congruent to the first and the last on the second triangle, XZ. And that's what the congruency statement shows us. Everything that's congruent in the triangle. In order to tell whether 2 triangles are congruent, you only need to find 3 congruent things. Now there are many different combinations of the 3 congruent things you need. And we're going to cover the ones that actually do prove congruency. But there are also 2 other combinations that do not. Our combinations would be 3 sides, 1 side, and 2 angles, 2 sides, 1 angle, and 3 angles. Now, like I just said, not all of these combinations are going to work. So let's go over the ones that do prove congruency, then we'll talk about the ones that don't. The first one is if you're given that all 3 sides are congruent. So if I knew that this side and this side were congruent, and this side was congruent to this side, and this side was congruent to this side, then I would know that these 2 triangles are congruent based on side, 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 or S, S, S. The next situation is 2 sides and 1 angle. But there are 2 different ways you can have this. You can have side angle side, otherwise known as SAS, which does prove congruency, or you could have a different one called SSA, which does not prove congruency, or as others would put it, ASS, and there are no donkeys in triangle congruence. Okay? So the only one that does prove it when you have two sides and one angle is side, angle, side. That would be, you have one side congruent to corresponding side on the other triangle. Then the angle has to touch the side that's already congruent, and it has to be congruent to the corresponding angle. And then the other congruent side also has to touch that congruent angle. And as you read it, when you read it, it'd be side, angle, side. Side, angle, side. You can hop around the triangle to make side, angle, side. Our next scenario is two angles and one side. Now, both of the scenarios here, angle, side, angle, known as ASA, is in fact a way to prove triangle congruence. In this one, we have two congruent angles. So let's say this angle and this one, and then this angle and this angle are congruent. Now, for it to be angle, side, angle, the side that is congruent has to be between those two angles. So it would have to be this side right here. That's angle, side, angle. Now let's look at the other scenario with two angles and one side. Angle, angle, side, also known as AAS. In this one, you still have two congruent angles in your triangles. But on this one, your side only has to touch one of those angles. For instance, I could use this side here. Now I could have chosen the other side that doesn't touch both angles. It wouldn't have mattered. It would still have been angle, side, angle. As you'll see here, angle, angle, side. Angle, angle, side. Okay? The final way to tell if the triangles are congruent has to deal with only if it's a right triangle. This is the only one that has the stipulation that it only works if it's a right triangle. And that is hypotenuse leg, abbreviated HL. Okay? Hypotenuse leg means your hypotenuses are congruent, and one of the legs of the right triangle